Let's try a SOHCAHTOA trig question that mixes in volume. So what is the volume of this cone? Recall the volume formula of a cone. You can look it up at the back of your provincial. It's going to be the volume of a cone. Recall, it is 1/3 the volume of a cylinder. So this here is equals to 1/3. The volume of a cylinder is going to be the area of the face times the height. So the area of the circle, the face, it happens to be a circle, is pi r squared times the height. So this here is h, and this here is r. So one key step in solving this is to copy this 10 over here. You have to recognize that and assume that this cylinder is straight and balanced. So this is 10, this is 10. And because we have two pieces of information, using SOHCAHTOA, we can find some unknown. Let's focus on the radius first. I'm going to put our finger here on this 15 degrees and think about what we have here. We're interested in the opposite and the hypotenuse. This is the opposite from the finger, and this 10 is the hypotenuse. Let's write it out here. We have SOHCAHTOA. We're interested in the opposite and the hypotenuse. This happens to be so. So what we'll say here is the sine of some angle 15 is equals to the opposite, which happens to be r, over the hypotenuse, which is 10. Remember that the trig function of some angle is simply a number. This here is simply basic algebra. You multiply both sides by 10, we have r is equals to 10 times sine 15. And if you're using your calculator in degree mode, we evaluate r to be approximately equals to 2.5882. And because this is a multi-step problem, we're not just solving for r, we're solving for something that involves r. We really should hang on to at least 4 decimals. In fact, it's better to even reuse the value in your calculator. So we successfully solved r. So r is solved, and this happens to be r over here. Now let's solve for h. So what we have here is your fingers on the 15. We're interested in the adjacent and the hypotenuse. This here is the adjacent, not the opposite. This is the adjacent to where your finger is, and the hypotenuse. So we're interested in the adjacent and the hypotenuse. We're going to use cosine. So the cosine of some angle 15 is equals to the adjacent, which happens to be h, over the hypotenuse, which is 10. So h here is going to be equals to 10 times cosine of 15, which is approximately 9.6593. So we solved h. So by plugging in this r value, and don't forget the square here, plugging in this h value, we carefully evaluate the volume to be approximately 67.8. And because we're talking about volume, we're talking about units, meters cubed. Your answer might be slightly off by 1/10 of a decimal if you chopped off your decimals. I actually used the full calculator values to solve this problem. So the key here, even though we're given some volume problem, is to remember the formula. We're talking here about a cone, but this could be any shape. This could even be a pyramid, which also follows the the pattern of 1/3 of a box, the volume of a box. So once you have the formula, you just have your variables, which happens to be the height and the radius here, and remember to copy over the number and think about it. Do you actually have two pieces of information to work with SOHCAHTOA? And we do. We have two pieces of information. Here we have the angle and a side length, and using SOHCAHTOA you can actually solve for R, and then using SOHCAHTOA again we can solve for H. Plug in your values carefully, use your calculator carefully in degree mode, and you should evaluate the answer correctly.